Welcome, and thank you so much for joining us for this conversation and discussion about recycling carbon dioxide into sustainable aviation fuel. We're talking about a flight plan for carbon neutrality, fuel diversity, and national security. My name is Volker. I'm a professor of mechanical engineering at the University of Michigan. I serve as the director of the Global CO₂ Initiative and the faculty director in our Center for Entrepreneurship here at the University of Michigan. It is my distinct pleasure today to have this conversation with Robert Schuetzle, who is an alum of the University of Michigan, and more excitingly, in the context of this discussion, he is the CEO of Infinium. And I invite Robert to say more about himself as well as the company, and then we'll get started with a conversation that will lead us eventually into an open period for questions on comments from the audience. Robert, thank you so much for joining us this morning.
Thank you, Volker. First of all, thanks to you and the University of Michigan's Global CO₂ Initiative for sponsoring this webinar. We're always excited to talk about e-fuels and sustainable aviation fuel and decarbonizing air travel. So I'm Robert Schuetzle. I'm CEO of Infinium. Infinium is an e-fuels company. E-fuels is the production of drop-in transportation fuels like sustainable aviation fuel from waste CO₂ and renewable power. That's where the E comes from in e-fuels. Infinium is both a technology owner. We have over 300 patents. We manufacture our own proprietary catalysts that go into our gas conversion systems. And in addition to being a technology player, we're also a project developer. We construct projects and we operate these facilities. So we sit on both sides of the equation in the e-fuels ecosystem. Myself, as you mentioned, I graduated from University of Michigan, mechanical engineering as well, go blue. Many years ago, I had a number of years in industry and consulting, engineering, technology, before I co-founded our predecessor company to Infinium. That was many years ago, over 15 years ago. We focused initially on gas to liquids, converting hydrocarbon gases like natural gas, flare gas, waste gases into fuels and chemicals. And then in 2020, really jumped full on into the e-fuel space. 2020 was only 5 years ago. And at that time, discussions around sustainable aviation fuels and e-fuels were very, very early. And even the terms weren't quite defined. So I think we've come a long way in a short 5-year period, which is warp speed for the energy industry. And excited to talk to you about where things are going today in e-fuels and SAF.
Excellent, and thank you so much. So I think we should first sort of set the stage by really re-emphasizing why does SAF matter now, and why is getting to net zero in aviation so uniquely hard, and how does SAF fit into a company's net zero energy today and of course in the long run.
So long haul transport, heavy transport, is inherently very difficult to decarbonize. If you take small vehicles, battery electric is a good solution, but when you go into heavy transport, which might be long haul trucking, maritime, and of course aviation, these are large vehicles and it's challenging to get the power that you need without energy dense liquid fuels. So switching types of fuel is very challenging. If you think about a 747, I don't think in my lifetime or my kids' lifetime we're going to have battery electric 747s. So you really need that energy dense aviation fuel that we've used for decades. So that's why the aviation industry is really looking to sustainable aviation fuel. It is a drop-in transportation fuel. We can use the existing vehicles we have today. We can use the fueling infrastructure that exists around the world and at every airport today, but it allows the airlines and the industry to immediately decarbonize by using SAF as a drop-in fuel to lower their carbon intensity with a specification fuel that they've already used. So we see SAF trending today for a variety of reasons. Number one, voluntary targets. Number of airlines have put out net zero carbon goals. They vary, but they're very aggressive, and SAF is a key element of getting there. Customers are demanding decarbonization from the airlines as they travel for vacation, for business as well. So those are voluntary goals. And then we'll talk quite a bit about some of these mandated markets that have emerged that are requiring airlines as well as obligated parties to have sustainable aviation fuel in the mix. So I think there's a number of drivers and reasons for why SAF has become such a trend today.
Yeah, thank you so much for really laying this out for us here. And building on that, SAF seems to be sort of one thing, right? And just like we understand there's aviation fuel, and to us who just board a plane and fly, that's enough to know. But when it comes to actually delivering it looks very, very different. I think it would be useful to our audience if you could walk us through different SAF pathways, how they can be sourced, made, etc., and then specifically come to the core of our discussion here, and that is eSAF and how it might differ from other SAF types in the context of it still has to meet what an airplane can actually burn.
Great. You're right that all SAF is not created equal. And it is all called SAF and it meets these physical specifications, but there are different pathways to get there through the production of sustainable aviation fuel. So today, aside from SAF, all fuels, aviation fuels are produced from petroleum. It's refined into a kerosene that is an aviation fuel and goes into our infrastructure today. So that's predominantly what we use when we travel on aircraft. SAF, again, is the same chemical composition, meets ASTM specifications, so it can be used in these vehicles, but it's produced from different feedstocks. So I'll break it down into three categories that are widely discussed today. First category, which is the predominant amount of SAF used in the market today, is called HEFA-derived SAF. So HEFA stands for hydroprocessed esters and fatty acids. Let's call this a generation 1 sustainable aviation fuel. And HEFA feedstocks might include used cooking oils or UCO, animal fats, and other waste oils. So think about these feedstocks as kind of a surrogate crude. They're hydroprocessed in a refinery type process to produce fuels. Diesel can be produced from that. That's generally what's referred to as RD or renewable diesel. But then taking it a step further, it can be turned into sustainable aviation fuel. That is pretty much the SAF market today, as this market has emerged, is HEFA-derived SAF. And then we'll talk about why that will be challenged in the future. It's a great place to start, but HEFA-derived SAF is inherently feedstock limited as we look at feedstocks worldwide to produce aviation fuel. But that is pretty much the SAF market today. As we move on to generation 2 sustainable aviation fuel, two categories there. The first is called alcohol to jet, or ATJ. That is an emerging marketplace, emerging technologies. You'd start with an ethanol or methanol or isobutanol. Those could be existing molecules in the market today, traditional ethanol, or they could be produced from alternate resources. And then to get from that alcohol to the jet fuel, there's a number of refining steps that need to happen. Dehydration to take that alcohol to an ethylene or an olefin, oligomerization to turn it into heavier hydrocarbons, and then refining steps after that. So a number of steps to go from that alcohol to jet. Again, that ATJ category is emerging, a number of players working on that pathway. And that does get you a better carbon intensity reduction than HEFA-derived SAF. So that's one of the drivers of going to ATJ. The third category, and what Infinium focuses on in the second generation ecosystem here, is e-fuels or eSAF. This is taking waste CO₂ that would otherwise be emitted to the atmosphere, a greenhouse gas, and renewable power to produce green hydrogen. That carbon and hydrogen are paired. Those are our inputs, hydrogen and carbon, to produce a hydrocarbon fuel. And we turn that into a specification ASTM certified sustainable aviation fuel. So different feedstocks, different technical pathways. eSAF does has the potential to get a much lower carbon intensity, close to 100% reduction over petroleum. So is more advantage than the other two categories as these emerge. So we'll talk about some of the puts and takes, some of the pros and cons of each of the
Mhm.
platforms, and where we see the future going a little bit later. But those are generally the three that are talked about in the marketplace today.
Yeah, that's actually very interesting to see that there is sort of a first generation type of fuel that is limited and therefore probably will not find too much new investment and deployment. So that is kind of a boundary condition that I think people need to understand. I do wonder though if we talk about all of these fuels, they all need infrastructure that sounds very similar to me, like a chemical factory, a refinery. You mentioned that even specifically. Um, so so how do we think about taking CO2 and recycling that into something that's valuable? I mean, here we focus on aviation fuel. Of course, other things can be made, but I mean, what is needed? I mean, this is the traditional oil and gas industry is a huge industry. It takes much more than just drilling a hole in the ground and putting a pipeline to a pump. How is that with CO2 based e-fuels and the work that you do at Infinium?
Sure, you're absolutely right, Volker. This industry, whether it's our category of SAF or the others, require significant infrastructure. And that's
Mhm.
why infrastructure investment into this space is very much needed. So, Infinium, as I mentioned, is both a technology company and a project developer. So we sit on both sides of the equation. And in order to get a plant operating to produce sustainable aviation fuel, we need a lot of infrastructure that takes that waste carbon and produces that SAF. So let me walk you through the process and the technological blocks,
Mhm.
and then we can give some examples of the projects that we built, our Corpus Christi facility called Pathfinder, and then one that's under construction. So we first, when we look at project development, we have to start with a CO2 source. So where does a CO2 source exist that we can purchase under long-term contracts, because that's a critical carbon feedstock we need for our facilities. I will say years ago, I always had visions that we would get the CO2 for free, or someone would pay us for the CO2. I think inherently human nature, even if it's a waste product that you've vented for 40 years, we've never gotten away for not paying some monetary value for the CO2, which we're happy to do for a dedicated contract. So any of the folks listening to this, if you are a CO2 owner, we are a buyer and we can turn that liability into a revenue stream, which we think is really important for the CO2 recycling industry, is to really pay that CO2 owner for value that we would derive from that waste product. So we start with the CO2. We then pair that with green hydrogen. Green hydrogen is produced from the electrolysis of water, requires renewable power input, so wind, solar, geothermal, hydro, low carbon power, nuclear can be used in some situations as well. We're excited about that industry advancing. And then we split the water into green hydrogen. Now, Infinium is not an electrolyzer player. There's 100 players in the marketplace. We're excited about the evolution of electrolysis and the cost down potential of electrolysis. It is our most expensive input to e-fuels. So very important as we look at getting to parity with fossil fuels is that electrolysis block and that green hydrogen. So now we have CO2, our carbon input. We now have hydrogen, our hydrogen input, and we take it into our proprietary technology. This is where our gas to liquids platform comes in. This is our own flow sheet and our own catalysts. And these facilities, they do look like refineries, even though they're taking a different feedstock. They use pumps, compressors, and stuff that the oil and gas industry has used for decades. The first step in this process takes the CO2 and hydrogen and converts that into syngas, basically reduces that CO2 into carbon monoxide and hydrogen. That's in the industry called syngas, or H2 and CO. That's an intermediate gas that's used in production of many products. And then our second process takes that syngas and directly produces middle distillate liquid fuels in the kerosene range. So that's a second proprietary catalyst. Ours is an alternative to traditional Fischer-Tropsch, if you've heard of that term, or FT. It is in that family, but it is different in that we don't produce waxes. We actually produce those middle distillate liquids. We then treat those a bit to make SAF specification, and that's what results in the SAF. So quite a bit of kit that goes into this, Volker, as you mentioned, requires large infrastructure, commitments to build these facilities. We built our first facility on our own balance sheet, and it started operating in 2023. We have 2 electrolyzers at our Corpus Christi Pathfinder facility producing green hydrogen, 2 ISCC Plus certified CO₂ sources that otherwise would have been vented to atmosphere, producing liquid fuels at that facility. So as we scale, large commitments from infrastructure and backstop by offtake agreements from airlines are required to build this. So that's our process, but alcohol to jet, similar large infrastructure, and even HEFA-derived SAF requires these major infrastructure commitments to build out plants that produce sustainable aviation fuel.
Yeah, well, thank you so much for breaking that down to us. And it certainly sounds like a lot of not only money, but also expertise is needed to not just conceive and plan such a facility, but also to run it. So it sounds to me that benefiting from existing industries in the chemical and petrochemical industry is helping to attract talent, so that we don't have to start from scratch and sort of work on that workforce development as a starting point in the first place. In somewhat of a turn of the conversation, I'd like to sort of reflect on the ability to take CO₂ from wherever it is, and fundamentally this could be the air. If need be, we could even draw water from the air and electrolyze that. So we had all the building blocks to make fuel, assuming we have electricity, anywhere around the world. And in a sense, one might ask, well, is that useful, needed, or how should we go about this? Well, and I think one area where this could become actually quite essential is when we talk about national security and military fuel resilience. Is that something that you see happen in the SAF space or e-fuel space? And what are implications? What are drivers here in that case?
Yeah, it's a great question, Volker. We have been looking at that, and we do believe in the medium to long term, it's certainly a great application. I mean, when you think about aviation fuel today, it is a very centralized industry. It requires oil production, delivery to a refinery. That refinery produces aviation fuel, and it has to be delivered to wherever it's used. And in a military application, that could be very challenging in that supply chain to both get the oil and to a secure refinery. Relying on refinery, there's very few of them globally as a count, and then delivering that aviation fuel to wherever it's needed. So quite complex and a risky supply chain to get that to where it's needed. When you think about e-fuels, these are smaller distributed plants that could be deployed in any geography. And while today Infinium uses point source emissions from existing industrial or biogenic sources, we're very optimistic about a category of technology that you mentioned is direct air capture. There's a number of direct air capture companies. I read a report the other day that said there's 100 players working on DAC. So we're very excited to see technology mature as well as get to scale. Oxy, with a company they acquired called Carbon Engineering, is building a massive direct air capture facility in West Texas, a place that we know well with our Roadrunner facility. So we see DAC moving along. But if you take DAC and assume that that is commercial, and you also take the availability of renewable power or even small nuclear power in these areas, these could be totally self-contained fuel production facilities at small scale to deliver aviation fuel for military or other applications. We see other applications as well in these distributed environments. So unlike centralized production as well as these complex supply chains, we believe e-fuels has the opportunity to be widely distributed throughout the world for military and other applications.
Mhm. In those cases where there is an additional strong market force, not just I need the fuel, but I need for specific reasons and with constraints, are procurement mandates or procurement opportunities helping ESAF to build strategic advantage? Is that something that can also help your emerging industry to grow in a somewhat less financially constrained context?
Great question. For e-fuels, and I think for SAF in general, there's two general drivers for the market. There's voluntary drivers. These might be net zero carbon goals. These might be customer commitments to airlines for Scope 3 emissions. And then, as you mentioned, there are mandated markets that have evolved over the last couple of years. There's a number of them now, which is exciting for us. And
Mhm.
in addition, in two of those large mandated markets, there are sub-mandates in addition to a broader SAF mandate for eSAF. So let me talk about two of those. The first is the United Kingdom. The UK has a SAF mandate, but they also have a sub-mandate for eSAF, our category of SAF,
Mhm.
in that market starting in 2028. And the penalties can be fairly significant for the obligated parties, including the airlines. So that is driving demand for the e-fuels and helping to get deals done. One of our customers for our Roadrunner facility that's under construction in West Texas today is IAG Group. They own British Airways, Aer Lingus, Vueling, and other brands. And we do have a long-term commitment from them from the Roadrunner volumes to ship SAF over to the UK. This will be used at Heathrow to help them meet their mandates under the UK e-fuels mandate, again, that's starting in 2028. So that's an example of a mandated market. A larger mandated market that is emerging is the EU. The EU now does have a SAF mandate, and their sub-mandate for eSAF starts in 2030. The penalties in the EU are higher for not having eSAF, and regulators, even in the last few weeks, have come out publicly in the market to communicate that they are staying firm on their target for e-fuels and encouraging everybody to get to work to get volumes into the marketplace, which Infinium and our partners are working very hard to do to get supply into that market before that 2030 mandate to help our customers meet those obligated targets. So again, voluntary requirements as well as mandated requirements, but the mandated markets are picking up. We're seeing emerging mandates in places like Singapore and other marketplaces. We expect to see some more, so that will continue to drive demand, while e-fuels are more expensive today in the market than fossil-derived fuels. Now, we'll talk about it as well, but we do see a path to parity. Ultimately, you have to stand on your own and not have mandates or subsidies, but today it's more expensive, so we do need those premiums in the market to build these facilities.
Right. Well, thank you so much. And I think on the voluntary end, I think I'm excited to have just learned that the University of Michigan is renewing its investment in advancing SAF with a new 3-year partnership with Delta Airlines that aims at reducing our greenhouse gas footprint. I mean, the university overall aims at carbon neutrality on a record pace. So this is all helping, and I'm glad that you have shared with us what kind of pathways exist. So to make this all happen and work towards that parity in terms of cost, et cetera, we should sort of revisit some of the unique feedstock benefits that CO2 brings and market hedging that we may have overlooked before we open up questions to the audience. So overall, you see that CO2 really is an advantageous feedstock compared to biomass or waste oils. Is there an additional reason that at some point, we just cannot go without CO2 if we want to continue flying, or at least, as everybody tells us, people want to fly more. So is guilt-free flying, the access to guilt-free flying, rooted in CO2 to SAF?
Well, we certainly think so, Volker. CO2 resources are massive. Of course, there's a lot of emissions, and again, with direct air capture maturity, it's basically infinite. So the feedstock availability is there. And when you look at the HEFA category, one thing that's challenging there is feedstock limitations. So if you break
Mm.
down those categories that make a HEFA feedstock that can be refined into SAF, you're talking about used cooking oil, animal fats, other waste oils. Maybe you have 10, maybe 15 million tons of each of those categories worldwide. Those are rough numbers. I've read different studies, but that's an ultimate maximum feedstock that you could, if you sucked up every bit of used cooking oil from your McDonald's French fryer, et cetera, around the world and everywhere else, that would be an ultimate maximum. So it's a very distributed feedstock source. There's competition for it. It's harder to aggregate. But even if you took all of that feedstock and converted it to SAF, and you do get a conversion efficiency from that volume into your SAF. In addition to SAF, you produce LPG, you produce diesel. So it's not 100% into SAF. But even with that, you're still talking about a single-digit percentage of the overall aviation fuel supply. So again, even if we were 100% efficient in HEFA-derived feedstocks into SAF in that marketplace, and all of that feedstock could be captured, you're still not even tipping above that 10% of overall aviation fuel supply. And I've read a number of studies that say it's on the lower end and higher end, but it's always a single digit. So ultimately,
Mhm.
we need another pathway to provide the sustainable aviation fuel, and with CO2 availability and renewable power growth in markets that it's accelerating, and some of these areas that are stranded renewable power to get to market, they don't have the grid transmission. We do see the e-fuels category as filling that gap, and ultimately can be more cost effective when the cost curve comes down, because you don't have competition for those feedstocks like you do in the HEFA derived space.
Mhm. Yeah, thank you. So when it comes to competition, of course, you're competing against multiple SAF pathways, you're competing against the traditional fuel. Are these long-term contracts that you've talked about before some way to sort of flatten the fluctuations in the cost and hence the price of these fuels? I mean, if I look at the receipts that I get from an airline when I book a flight, I mean, it looks like formerly the phone bill, right? Lots and lots of entries, and sometimes there's a fuel surcharge. Um, so is such a long-term contract the right way to go, or are you, as the SAF producer, missing out on times when you could charge a premium? What works better for you as the the emerging future fuel deliverer?
Right. No, great question. And I'll first start by talking about how financing for these facilities work, because it's really important to answer that question. Our first project we built on our own balance sheet, supported by our investors in Infinium, which include University of Michigan, Amazon, NextEra, Mitsubishi, many Japanese investors. I can't list them all, but really great supporters of the platform over the last few years. So Infinium built its own facility in Corpus Christi, Texas, world's first e-fuels facility, started up in 2023, and it has been operating for the last year and a half or so. It really allowed us to take FID, final investment decision, on that facility without long-term commitments. We were able to lock in short-term commitments. We deliver fuels to Amazon. We ship fuels over to Europe. So that was the first facility. But as you grow up in the energy infrastructure arena, you really need to move to infrastructure finance. So this is equity and debt at the project level, not financed by us. So our next facility, our Roadrunner facility, it's under construction today, that is 10 times larger than Corpus Christi, was backed by Brookfield Asset Management, one of the largest energy infrastructure investors in the world, out of their energy transition fund. as well as Breakthrough Energy Catalyst. That's the infrastructure arm of Breakthrough Energy, and Infinium. We're a third investor as well, but majority owned by Brookfield. And then we did bring in a credit facility with HSBC. So in order to get that kind of finance at the project level, you do need these long-term commitments. And we're very fortunate that two airlines that are really put their foot forward in this eSAF industry made long-term commitments to the Roadrunner project. The first I'll highlight is American Airlines, who we did our first deal with. Long-term commitment for eSAF. It is voluntary volumes delivered here in the United States, so it's not a mandated market. And in conjunction with the American Airlines deal, Citi committed to buy Scope 3 emissions from American Airlines. So really a three-way deal to allow Citi to decarbonize and help hit their Scope 3 emissions goals and help American Airlines hit their goals. So that was one contract. Second contract was with IAG. I mentioned that in the mandated market of the UK. IAG did this a great deal with us for long-term commitments that allowed us to get the revenue certainty on this project in order to get to final investment decision. I think so in order for these facilities to get built, long-term commitments do need to be made. Some will be built merchant, but that's not the way the infrastructure capital environment works. They want really that revenue certainty that's not subject to market fluctuations. So would we be leaving money on the table in some of these mandated markets? Very possible. As you look at some of the penalties in the UK and the EU and the scarcity of e-fuels, I do believe that there is some money on the table because you're not going to get those maximums on the penalties from the airlines in long-term commitments. But long-term commitments are what are required in order to get the infrastructure financed. And then for the airlines, that does give them certainty on what the price is, and they can really look at those mandated markets and how the economics work. So I think in order for this infrastructure to get built, it's going to overwhelmingly be from long-term commitments that are required to get the finance in place.
Thank you so much for bringing this across with enormous clarity. I think we have a definite answer. I would suggest we start taking some of the audience questions so that we can hopefully address all of them while we're still online. If not, we might try to actually answer them in a short written posting so that nobody does get left behind in that context. I will say thank you so much, first and foremost, for illuminating this eSAF field for us in this conversation. It's complex, it's complicated, it's changing as we watch it. But I think you presented with great confidence that this is the future, and we will have to continue working on this. And I'd like to just pick almost randomly questions that I see here on screen that take us in various directions. The first one is more of a detailed chemical question, and that is, even though you talked a lot about sort of how you can tailor what you produce, not everything that you make is actually eSAF. What do you do with the rest? Is that sort of feeding into the chemical industry, or is this something that literally is waste and has to be dumped?
Yeah, great question. That's right. When you produce from that second step, the liquid fuel production, you get a range that's a little broader than the kerosene range. We do have optimizations to get as much as we can into sustainable aviation fuel because that's where the highest netbacks are. That's where the highest revenue is because of the markets we talked about today. But in some cases, we do have shoulder products, including what's lighter than the sustainable aviation fuel, which is called a naphtha. Naphtha is today traditionally produced from petroleum. It's used in a lot of applications, but it is also used in plastics production. Out of our Corpus Christi facility, a deal that we announced last year is with Borealis. We're shipping our e-naphtha over to Finland, where it's being turned into plastic intermediaries for a consumer products application that we hope to announce next year. Quite a bit of volume's already been produced. So, in some of these, again, shoulder products that don't meet the SAF specification, a high percentage of our product does go into the SAF range, but there are other market applications to help decarbonize, and plastics is an area we're very excited about.
Great, thank you. And I think along those lines is a question that talks about the first generation SAF being in a blend with traditional fuel. Is the future really that what you produce is 100% SAF? Or is there something we haven't looked at yet?
Yeah, great question. And it's a topic we didn't touch on. According to ASTM specifications, any SAF can only be blended at a maximum of 50%. So before you deliver the sustainable aviation fuel to market, it does need to be blended with petroleum-derived kerosene Jet A fuel. So that's a mandate today, and it's really focused on making sure that older infrastructure in the air doesn't have any problems. So that's why that blend mandate exists. Now, there are ASTM efforts underway and a lot of work to really move that up to 100%. But I will say practically today, we're well below that 50% blend wall, right? I mean, we're at a fraction of a percent. And when you think about the terminals or the tankage at these airports where this fuel ultimately goes, any SAF percentage will be blended down to a fraction of a percent. So while we think the efforts are important to get to 100% SAF, the industry volume is well below that threshold. So we've got a long way to hit that 50% tie-off. But that is correct. Any SAF, whether it's HEFA, ATJ, or e-fuels, does need to hit that 50-50 max before it goes to market.
Before we have to overcome that, we still have to build a lot of factories to make SAF in the first place.
Yeah.
So we're good on that end. And that more or less answers one other question: how much e-fuels could actually help close the loop on carbon in a circular carbon economy? I mean, there are limits for quite some time, but ultimately, I would think, tell me if you disagree, that it certainly will become an essential element in having a circular carbon economy.
Absolutely, Volker. I think if you look at the ultimate potential, and a lot needs to happen for this to work, but at our plant gate, we're essentially 100% CI reduction, carbon intensity reduction from petroleum-derived fuels. Now, we incur some carbon intensity to transport to market, a few points. If you did that in a decarbonized way, that would also be a zero. But e-fuels does have the potential to fully decarbonize aviation. As you mentioned, we're nowhere close to that today, but ultimately, in a long term, e-fuels could completely take carbon out of the loop in the aviation sector.
Thank you. Here's a question that asked about when ESAF projects would start developing in Europe. Is that something that's on your to-do list? And others, I'm sure, are thinking and hopefully working on that already as well.
Yeah, as part of our project development portfolio, as I mentioned, we built our first project, started operations in 2023, Corpus Christi, Texas. We call it Pathfinder. We'd welcome anybody to visit. It's a fun tour to see everything functioning together. Second project, backed by Brookfield, Breakthrough Energy Catalyst, and Infinium, with customers American Airlines and IAG Group, under construction in West Texas, out in beautiful Pecos, Texas. A lot of wind, a lot of solar out there, and much available CO₂. And then our project portfolio beyond that includes about 12 projects globally that are at various stages of maturity. So those also include US projects, but a number of European projects as well. One I'll highlight that we're very excited about is in Northern Norway. Northern Norway has excess hydropower. The grid is 100% renewable, and that hydropower has a hard time getting to European markets, which are much higher priced because of transmission capacity. So we're up there for the renewable power and the matching on those renewables. and then available CO₂ in that marketplace. So Infinium is active all over the world in project development, and we look for lowest cost production and match to our customers' requirements as well as regulatory obligations in the EU and the UK markets today.
Thank you. Just trying to see what other questions we haven't really looked into. There's one question that sort of combines CO₂ use with a sequestration provider who would otherwise send the CO₂ underground. Is there potential to become a sequestration provider? I think in a different sense, because you are releasing the CO₂ again. But what about a business partnership? Is that something that could actually make sense?
Sure. No, that's a great comment. While we don't do the sequestration side, right, both utilization and sequestration are needed. Some of our CO₂ partners are in that business where they have a model where they will sequester some of the CO₂ and then sell some of the CO₂ for utilization. So I do think in some of these larger CO₂ hubs, both approaches can be very effective. Oftentimes, these sequestration sites are limited by CO₂ capacity. So in order to take more on, they might have to have another outlet for that CO₂. So it's a very good comment. And in some of our partnerships that we're working on, those CO₂ owners are aggregating or looking at both sequestration and utilization with Infinium.
Mm-hmm. Now we all like regulations and the details of mandates, etc. But here's a question that I think deserves attention, and that is, if you produce your e-fuel in Texas, would that be eligible for compliance under the Refuel EU SAF mandate? Or is there something that also speaks about where fuels are made? Is that a general thing, or is that a specific EU question?
Right. No, really good question. So, fuels in general, and including sustainable aviation fuel and Gen 1 fuels that are in the market today, are a global marketplace. So, fuels are produced in one location and shipped to markets where the customers need them. So that's also the case for e-fuels. Our project in Pecos, Texas, called Roadrunner, as I mentioned, will be shipping fuels over to the UK to meet obligations over there with our customer IAG group. And same thing works for European mandates. Now, UK and EU mandates do have requirements around the CO₂ that can be used. They do have requirements around what constitutes renewable power into the e-fuels facility. So the regulatory requirements are fairly complicated. They're not geographic specific, so these fuels could be produced anywhere on the globe, including Texas or anywhere else, but you do have to look at meeting those requirements for the feedstocks and other obligations under the EU regulations or the UK regulations, which differ a bit.
Robert, thank you so much for all of the questions you provided, the deliberations, the insights that you have shared with me and our global audience. We did record this conversation with your permission, and we'll post that. I suggest that we take a look at the remaining questions and try to post answers to those as well. But for now, I realize that you actually have a factory to build and other things to do. So I want to thank you one more time for taking the time to join us here in this conversation. And best of luck to you, the company, and the future of aviation. Thank you so much.
Volker, thank you very much. Really appreciate the time. Thank you to all the attendees who joined this morning and the great questions, and appreciate the efforts from Michigan and the Global CO₂ Initiative. Go Blue.
Thank you.